All right. Um, so we're going to start to talk now about statistics. So remember that this unit of the class is all about probability and statistics, and so we've talked a lot about probability. We started off talking about how to count things, and then we talked about how probability is just a matter of like counting things up. Well, now we're ready to talk about some statistics. So let's get into it. So over the course of the next, I think, 4 lectures, we're going to talk about some statistics, and then we'll have your third unit test. Okay, but here goes nothing, right? So as a field of study, statistics, with a capital S, is the science of how to make sense out of data. Data, sometimes I call it data, but that's the plural form of the word. The singular form of the word is datum, D-A-T-U-M. So it's a weird Latin thing, right? But yeah, so let me zoom in a little. Okay, so, but anyway, when we calculate some kind of summary of data that's been collected, that summary is called a statistic with a lowercase s. So it's a little confusing, right? Because we use the word statistics to mean 2 different things, but statistics with a capital S is the field of study, and statistics with a lowercase s is some kind of numerical summary of data that you've collected. So statistics as a field of study is more than just about calculating lowercase statistics, right? There's more to it than that. One of the things that we do in statistics, in a statistics class, for example, is we learn how to sort data and how to organize it and all of that. So in this lecture, we're going to talk about how to organize data visually, how to organize it into charts, and then how to make graphs out of it. Okay. So the very first thing that we like to do when we're trying to organize data is we make what's called a frequency table out of the data. And what the frequency table does is it lists each category of data, and then it lists the number of occurrences for each of those categories. So to give you an example, right? Let's say that 25 viewers were surveyed to evaluate a preview of an episode of NCIS. I laugh. It just makes me think of my dad. He loved that show for some reason. Anyway, the possible evaluations are excellent, above average, average, below average, and poor. So E stands for excellent, A stands for above average, V stands for average, B stands for below average, and P stands for poor. Okay. So after the show, the 25 evaluations were as follows. So these are the results of the survey, right? So they asked the 25 viewers, what did you think about the show? And this person said, oh, it was above average. This person said, oh, it was average. This person said it was average. This person said it was below average. This person said poor. This person said excellent. So that was my dad right there. Anyway, so that's just, we call that just the raw data. You haven't tried to organize it or summarize it in any way. It's just the raw data. So let's take that raw data and construct a frequency table for it. Okay, so the frequency table is going to list the categories. In this case, the categories are the ratings, right? The ratings: excellent, average, excellent, above average, average, below average, poor. So we're going to have a column for ratings. And then we'll have another column for frequency. The frequency is the number of times that rating occurred. Okay, so it's the number of times that rating occurred. So let's write it down. So the different kinds of ratings were excellent, above average, average, below average, and poor. And we can count up how many times each of those occurred, right? So how many E's are there? How many people rated the show as excellent? Well, there's 1, 2, 3, 4. So I think 4 of those. How many rated it above average? There was 1, 2, 3, 4, 5, 6, 7. So it looks like 7 of them. How many people rated it average. 1, 2, 3, 4, 5, 6, 7, 8. How many people rated it below average? There's 1, 2, 3, 4. So it looks like 4. And how many people rated it poor? Looks like 1, 2, 2. Okay, that's a frequency table. So that's all there is to it. Now, one thing that should be true is that when you add up all of these numbers, so as a way to check your work, to make sure you did it correctly, when you add up these numbers, you should get 25, right? So, I know that's 15, 19, 23, 24, 25, right? So yeah, but if you add those up, you should get 25. Okay, so that's a frequency table. Another thing we like to do is calculate the relative frequency. So the relative frequency is the proportion or the percent of observations within a category. And the way that you calculate the relative frequency is you take the frequency and then you divide it by the total, right? You divide it by the sum of all the frequencies. Okay, so that's the relative frequency. So a relative frequency table is going to list the relative frequency of each category of data. Rather than just the frequency, it'll list the relative frequency. So let me give you an example of that. So this one says, a physical therapist wants to get a sense of the type of rehabilitation required by her patients. To do so, she obtains a simple random sample of 30 of her patients and records the body part requiring rehabilitation. Construct a relative frequency table of the location of injury. Okay, so here we have all the locations. So again, this is just raw data, right? So she selected 30 patients in it and, you know, determined where their injury was, right? Okay, so if we're going to create a relative frequency table, first we need to list off the categories. And the categories in this case were the locations of injury. So I'm just going to call that injury location. And in order to get the relative frequencies, first I need to know what the frequencies are. So I'm going to make a column for the frequency. And then I'll be able to make a column for the relative frequency. Okay, so injury locations. What locations did we have? Well, some people had back injuries. All right, so back should be on the list. Some people had a hand injury, neck, knee, wrist, back we already had on there, groin, shoulder. I'm going to run out of room unless I start writing smaller. Elbow, and hip. So I'm going to have to squeeze the last two on here. Elbow and hip. Okay, so those are all of the locations for the injuries. I think that's all of them. If we need to add one on there, then we'll go back and add it on. But let's go and count these up now. So how many people had back injuries? Looks like we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it looks like 12 back injuries. Okay, how many people had hand injuries? That looks like 1, 2, just 2 people. How many people had neck injuries? 1, just 1. How many people with knee injuries? That looks like 1, 2, 3, 4, 5. Okay, wrist injuries. We've got 1, 2. Groin injuries. It looks like 1, just 1 maybe. Shoulder injuries. It looks like we've got 1, 2, 3, 4. 4 shoulder injuries. elbows. We've got 1. How do you injure your elbow? Hit your funny bone really hard, I guess. 1 elbow injury, and then hip injury. How many of those? Just the, 2. We've got 2. Hip and hip. So 2 hip injuries. Okay. So again, if I want to check my work, it says that she sampled 30 of her patients, so this should add up to 30, right? I'm going to punch that into my calculator because I don't feel super confident. 12 plus 2 plus 1 plus 5 plus 2 plus 1 plus 4 plus 1 plus 2 is 30. Okay, so I must have done it right. Okay. So now, to get the relative frequencies, I'm going to divide each of the frequencies by the total, which is 30, right? So to get the relative frequency for back injuries, it's going to be 12 divided by 30. And then I can use my calculator to change that into a decimal, right? If I just type in 12 divided by 30, I get 0.4. Here I'm going to do 2 divided by 30. I get 0.0666, and I'll round to 3 decimal places on this, so I'm going to say 0.067. Okay, 1 out of 30. 1 out of 30 is 0.033 approximately. Okay, and so forth, right? So 5 out of 30, 2 out of 30, 1 out of 30, 4 out of 30, 1 out of 30, and 2 out of 30. And let's see. So this is about 0.167, 0.067. Oh, and I've done a lot of these already, right? This is 0.033, 0.133, 0.033, and 0.067. Okay, so there's my relative frequency table, and that's all there is to it. Now, on the previous page, I said that the relative frequencies was either the proportion or the percentage. When you leave it as a decimal, that's the proportion. If you change it into a percentage, you have to move the decimal twice, right? So this would be 40%. This would be 6.7%. This would be 3.3%. Okay, you don't have to change them all to percentages, but I just wanted to point that out. If you leave them as decimals, that's the proportion. If you change it to percentages, that's the percentage, obviously. But in either case, we call that the relative frequency, right? So we would say, I kind of like thinking of them like percentages because it's easy to tell now. Like if I look at this, I can tell that 6.7% of her patients had a hand injury, right? And 3.3% of her patients had a groin injury, right? 40% of her patients had a back injury, right? So I kind of like thinking of them like percentages personally. But anyway, so that's how frequency and relative frequency tables work. So moving on, okay. So qualitative data consists of information about a characteristic such as eye color or gender, whereas quantitative data consists of data that is obtained by measuring or counting something. So the previous two examples were examples of qualitative data. Okay, so in the first example, the data were not numbers, they were ratings, right? Excellent, above average, average, below average, poor. Okay, so if the data is numerical, then it's probably quantitative, but this wasn't, right? So we call it qualitative. You're talking about the quality of the show, not how much of the show you watched or something. You're just talking about how good it was, right? In the second example, the data were not numbers, but body locations, back, hand, neck, right? So those were both qualitative. Those are both qualitative data. If the data are numbers, then the data are probably quantitative. So for example, a person's height would be quantitative, right? So if you went out and surveyed a bunch of people, said, how tall are you? And some people are like, oh, I'm 63 inches tall, I'm 72 inches tall, you know, whatever. Then what they're reporting to you are numbers, right? 63, 72. So that's called quantitative, right? It's called quantitative because you get that data by measuring their heights, right? So you get the data by measuring or by counting something, then it's quantitative. Okay, so the last two examples we saw, we were organizing qualitative data into frequency and relative frequency tables. Organizing quantitative data into frequency and relative frequency tables can be a little bit more confusing because with qualitative data, the categories were just words and the counts were numbers. With quantitative data, the categories are going to be numbers and the counts are also going to be numbers. And so it's easy to confuse yourself. So we'll try not to do that as we look at a couple of examples. But one of the things that I want to point out before we do is that with quantitative data, if there are a lot of categories, I should say categories. If there are a lot of categories, then we'll usually group those categories into classes. And I'll describe what I mean here in a second. So, so suppose that 20 school counselors take a test to evaluate their skill at identifying signs of depression. And they earn the following scores, right? So they're rating the school counselors on how well they can identify signs of depression. So one person got a 79, one person got a 62, another person got an 87. So they're pretty good. They're pretty good at determining if somebody's depressed, right? This person who got a 51 is not very good at determining if somebody's depressed, right? Anyway, but notice that the data here is numerical. In other words, quantitative. This is quantitative data. We're asked to construct a frequency and relative frequency table for these data. Okay. So just like with qualitative data, we're going to list off the categories. In this case, the categories would be their scores, right? It would be what score they got on this particular test. So okay. So it would be really tempting to just say, well, what are all the possible scores? The smallest one is 51, so you could say 51, 52, 53, 54, 55, all the way until you get up to the largest one, which I think is 87. So you could just list off 51 to 87. But then the frequencies on each of those are going to be like 1, 1, 1, 1, 1. It's not going to really organize the data very well. Okay? So instead, we're going to create classes. Okay, we're going to create classes. So we're going to say, instead of just one category being the score of 79, we're going to make a category that's the score, all of the scores between, say, 50 and 59, right? So maybe I'll put all of the scores between 50 and 59 as one category, right? And then the next category would start at 60 and go from 60 to 69. Right? And then the next category would go from 70 to 79. And by the way, it doesn't always have to be by tens. It could have been by fives or by threes or whatever. This is just the way that I thought, because I don't have a ton of space to write down this frequency table, this is kind of the way I thought to do it. But we need to go all the way up to like probably 90. So the next one will go up to from 80 to 89. And actually, I think that's probably good enough. But let's go through and count them now. So first I'm going to go through and count up all of the people who scored between a 50 and a 59. So how many of those do I have? There's one. There's another. So I think I've got two. Then I'm going to go through and count up all the ones between a 60 and a 69. So there's 1, 2, 3, 4, 5, 6. Then I'll count up the ones between 70 and 79. So there's 1, 2, 3, 4, 5, 6, 7. And then I'll count up the ones between 80 and 89. So I've got 1, 2, 3, 4, 5. So I've got 5 of those, right? So that's what my frequency table would look like when I've grouped the data into classes. So these are called classes. Okay. I wanted a relative frequency table for this as well. So there's my frequency table. If I want a relative frequency, then I need to add another column. Okay. And what's the total here, right? So it should be 20 because I had 20 school counselors. So let's see. 5 plus 6 is 11. Plus 7 more would be 18. Plus 2 more is 20. So I think that's good. So then my relative frequency of people who scored between 50 and 59 is going to be 2 out of 20, which is 1/10, which is 0.1. For people who scored between 60 and 69, that would be 6 out of 20, which is 6 out of 20, right? Which is 3/10. So 0.3. 70 to 79, there was 7 out of 20 people. Oh, that's harder to do in my head. I think that's 0.035, 35%. And then 80 to 89, that would be 5 out of 20, which is 1/4, which I know is 0.25. And by the way, when you're welcome to use your calculators on this, but when you add these up, you should get 1, right? So 0.25 plus 0.35 is 0.6, plus 0.3 more would be 0.9, plus 0.1 more would be 1. So that works. Again, you're welcome to use your calculator. Okay. Sometimes on some problems you might be told, so like here we just chose to go by tens, but on some problems you might be told don't go by tens, go by threes or something, right? So we need to know what language they're going to use when they ask us to do this kind of stuff. So here's the language they're going to use. So the starting point for each class is called the lower class limit. So like the lower class limit for this first class was 50, and the lower class limit for the second class was 60, and the lower class limit for the third class was 70, and the lower class limit for the fourth class was 80, right? So that's the lower class limit. The class width is the difference between lower class limits. Okay? So for example, if the first class in a frequency table starts at 5, so let's say the first class starts at 5 and that the class width is 3, then what that means is that the second class has to start at 5 plus 3, which is 8. Now, if the second class starts at 8, then that means the first class needs to end before 8, right? It needs to end at like 7.9 or something like that, right? Okay, so that's something that kind of throws students off a lot, because when they're making their frequency tables, they think, oh, the class width is 3, so the lower class limit should be 5, so the first class should go all the way from 5 to 8 because the class width is 3, right? But that's not the way the class width works. The class width is the difference between lower class limits. So if the first class starts at 5, then that means the second class has to start at 8, which means the first class has to stop at like 7.9 or 7.99 or something like that. Okay, so what was the class width in example 3? Well, we've said it already a couple times, right? But the class width, if you're looking at it like, oh, this goes from 50 to 59, so the class width is 9, you're wrong, okay? Because that's not what the class width is. The class width is the difference between consecutive lower class limits. So it would actually be 50 to 60 would be 10, right? So the class width is actually 10, right? So what's the class width in example 3? It's a class width of 10. Okay, so my advice, if you're given a problem where they tell you what class width to use, my advice would be fill in all of the lower class limits first, and then come back and fill in the end points for each class. So let me give you an example of that. This says construct a frequency table for the data below, which represents the length in centimeters of 40 fish from Black Lake. Use classes of width 5 starting at 20. So the class width is 5 and our starting point is 20. So we're going to separate this into classes. I'm going to do this over here so I have more room. But we've got, in this case, the numbers that are given here represent the lengths of a bunch of fish, right? So the categories are lengths. And in fact, we're told that the lengths are given in centimeters, right? So I'm going to say in centimeters, cm for centimeters. And we just want a frequency table, so I don't have to worry about the relative frequencies. Okay? So again, we want to use classes of width 5 starting at 20. So I'm going to start at 20, and then my class width is 5. So I'm not going to say that the first one goes from 20 to 25. I'm going to say the first one starts at 20, and the next one starts at 25. And then one after that's going to start at 30, and then it's going to go 35. Now, how far should I go? I see a 60. I see a 68. So probably I should go all the way up to like 70. I don't see anything bigger than 68. So I think all the way up to 70. So I'm going to run out of room if I don't start to space these closer together. But I'm going to go 40, 45, 50, 55, 60, 65. And I think that'll do it. I think that'll get me what I need. So the first class is going to go from 20 centimeters to, well, if the next class starts at 25, then the first class needs to end at 24, I suppose, right? And then the next one needs to go 25 to 29, 30 to 34, 35 to 39, and so forth. Ooh, I almost made the same mistake I told you not to make. There you go. Okay, now I can go back through and count up how many fish are in these classes. So how many fish are between 20 and 24 centimeters? Well, let's see. So I'm looking for the numbers between 20 and 24. So there's one. So just one. Next one, I'm looking for numbers between 25 and 29. 1, 2, 3, 4. So it looks like 4. Next one, 30 to 34. So I'm going to stop talking and just work, but I'll race you. See who finishes first. 30 to 34. So I think you get 5 there. 35 to 39. Okay, so I think this is what you end up with. 1, 4, 5, 6, 7, 5, 5, 3, 3, 1. Let me check. We should get 40, right? Because there were 40 fish in Black Lake. So if I add these up, 1 plus 4 plus 5 plus 6 plus 7 plus 5 plus 5 plus 3 plus 3 plus 1 is 40. So I think I got it. Okay, so that's what our frequency table would look like here. Okay, so that's how we organize data into frequency and relative frequency tables. Once we've done that, we might want to visualize the data in some way. And the most common way to visualize data is to make a bar graph or a histogram. A bar graph is used for qualitative data, so like examples 1 and 2. Okay, so for example, here are some bar graphs for the data in example 2. So this is a frequency bar graph of the body parts. Okay, and this is a relative frequency bar graph for the body parts. You'll see that like the shapes are the same. The only difference is that here we're listing the number of times that each injury occurred, and here we're representing the percentage or the proportion of times that each injury occurred. Okay, so these are bar graphs, and we use bar graphs for qualitative data. Okay, histograms are used for quantitative data. So for the examples in example 3 and example 4. So for example, here are some histograms from example 4. Right, this is a frequency histogram for the number of fish of different lengths in Black Lake. And so you'll notice that, you know, this corresponds nicely with what we did. 1, 4, 5, 6, 7, 5, 5, 3, 3, 1. Okay. And this is the relative frequency for fish in Black Lake. Okay. So if you look at these, you'll notice that really the main difference between a bar graph and a histogram is that in a histogram there are no spaces between the bars, and in a bar graph there are spaces between the bars. So if the data is qualitative, then you draw a bar graph with spaces. If it's quantitative, then you draw a histogram with no spaces. Okay? Now there are mathematical reasons for this, because notice that like here, where the data is qualitative, these are just categories. So this is, you're not even almost thinking of this as the x-axis, really. Whereas here, these numbers are quantitative, and so you can think of this as an x-axis. And so the reason the bar goes all the way over from 20 to 25 is because this bar represents all of the fish that are between 20 and 25 centimeters, not including 25, but all the way up to 25. And so the bars shouldn't have any gaps, because if there were gaps, then that would kind of suggest that, oh, well, there are no fish between, you know, 23 and 25 inches or something, which you don't necessarily know. So anyway, so that's kind of like the mathematical reasoning behind why histograms shouldn't have gaps. It's a minor detail, but it is important. So make sure that your histograms don't have gaps, but that your bars do. Okay. So let's look at a couple. How many examples do I have? A couple examples. Then I have one more thing I want to say. So this says, draw a frequency bar graph for the data in example 1. Use your work from that example to help you here. Okay, what was example 1? Let's remind ourselves. It was this thing with 25 viewers were surveyed to evaluate a preview of an episode of NCIS, right? This was the raw data, but this was the frequency table that we came up with, right? So let's make a bar graph out of this now. So it's E4, let me write these down so I can copy them over. E4, A7, V8, B4, and P2. Okay. Right? So our frequency table looked like this. E, A, V, B, P, and it was E4, A7, V8, B4, and P2. Okay, so that's the data that we had from example 1. So let's draw a frequency bar graph for this data. Here we go. So we'll start off by giving ourselves a little chart like this. And on the y-axis, that's where you're going to put your frequencies, right? So these are going to be the frequencies. So this is the frequency. And so you have to kind of decide, like, how big should I make my y-axis? Well, the largest frequency was 8, so this needs to go up to 8, right? So 1, 2, 3, 4, 5, 6, 7, 8. Okay. And then along the x-axis, that's where we put our categories. So E stood for excellent, so I'm going to write excellent. A stood for above average. V stood for average. B stood for below average. And P stood for poor. And then for each of those categories, I'm going to draw a bar. So for excellent, excellent was 4. The frequency was 4. So I'm going to draw a bar going up to 4. And since this is qualitative data, I'm going to draw a bar graph, which means I'm going to have spaces between my bars, right? For above average, it was 7. Some of you are going to be driven crazy by my messy bars, right? A lot of you can draw better bars than me, but that's all right. Average was 8. Below average was 4. And poor was 2. Okay, so as you can tell, this, and maybe we should give this a title. So maybe we should call this NCIS ratings, something like that. But this summarizes so much more nicely the data that was collected than just listing off the observations, right? Like just looking at these observations, it's hard to tell what's going on. But if you can see a graph of it like that, well then it's much more easy to tell what's going on. Like, most people thought that it was just an average show. A few people thought it was excellent. Not very many people thought it was poor, right? So that's just kind of a run-of-the-mill episode of NCIS, I guess. All right, so that's that. Let's do another one. This one we'll do from scratch. So it says, a professor has collected data regarding the increase in test scores by her students after a ban on the use of all social media during class. The data is organized in the table below. So I guess the idea is that if you're not allowed to look at social media during class, then you'll actually pay attention and learn something. Well, maybe not, right? But anyway, but this is the data that was collected, and it's already been organized into a frequency table for us, so that's nice. We're asked to draw a frequency histogram of the data. Yeah, I mean, it's going to have to be a histogram and not a bar chart because the data is quantitative here, right? The data is quantitative. That means that there's not going to be any space between the bars, okay? So let's do it. Frequencies, it looks like, I mean, I'm not going to include the 65 because that's just a total, right? But among the frequencies, it looks like the largest one is 23. So I'm going to draw my histogram like this. And my frequencies need to be on the y-axis. And I need to get all the way up to 23. So rather than writing a little dash for 23 times, I might just go by like 2s or 5s or something. 5 might not be enough. 5, 10, 15, 20, 25. It's going to be hard to tell, but maybe I'll go by 2s, right? So let's say 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Okay. So that's settled. And then as far as my as far as the x-axis goes, right? My classes, it looks like first class goes from 0 to 9.9, the second class goes from 10 to 19. So my class width is 10. So when I draw my histogram, I'm only going to put the lower class limits on the x-axis, right? So 0 to 10, 20, 30, 40, and then the next class would be at 50, so I'm just going to write a 50 here. And these are points, these are the points gained. Right, these are the points gained. Okay, so now I'm going to draw my histogram, and when I draw it, I'm not going to have any gaps between the bars. So the first class, 0 to 9.9, there were 14 people in that class. So I'm going to draw a bar at 14, and the bar should be between 0 and 9.9, right? So I'm going to draw it like that. Okay, so there's that first bar. If you want, you can put like another line on there. The next class should go to 23. Right, so the next class is 10 to 19.9, so it should cover all of this space between 10 and 20, right? And there's 23 in that class. So 22, so 23 is right between 22 and 24. Okay, the next bar should go from 20 to 29.9, so basically 20 to 30, and there's 17 people in that class. 16, 17 would be right there-ish. Okay, next class goes from 30 to 40. There's 8 people in that class, so right about there. And then the next class goes from 40 to 50, basically. And there are 3 people in that class, so 3, right about there. So that's what that histogram would look like. Again, I could give this a title. We could call it. We could call this increase in scores, or something like that, if we wanted to give it a title. But that's what that histogram would look like. Okay. So again, bar chart there, because the data was qualitative, right? The data were ratings, not numbers. Here, histogram, because the data was quantitative, because the data were numbers. Okay. Last thing is that we want to be able to use these kinds of graphs to answer questions about stuff. So let's go through this example. It says the histogram below shows the number of Atlantic hurricanes over a period of years. Okay, so let's just take in this histogram for a second. First of all, it is a histogram, not a bar chart, right? Because there's no spaces between the bars. So number of hurricanes per year is down here along the x-axis, and the frequency is along the y-axis. So when it says 4 over here, they're saying 4 hurricanes per year. And when they say that happened one time, we're talking about the frequency, right? So we're saying there were 4 hurricanes per year once, right? There were 5 hurricanes per year once. There were 6 hurricanes per year 6 times, right? So 6 years saw 6 hurricanes, right? There were 7 hurricanes in 6 of the years. There were 8 hurricanes in 9 of the years. There were 9 hurricanes in 4 of the years, right? So this is how you read the chart. There were 10 hurricanes in 6 of the years, 11 hurricanes in 10 years, 12 hurricanes in 5 of the years. There were 16 hurricanes in 0 of the years, right? And 18 hurricanes in 1 year. So that's kind of crazy, right? This year right here must have been a crazy year, right? 19 hurricanes that year. Thank goodness we're on the West Coast. No hurricanes. All right, so let's use this histogram to answer these questions. It says, what was the smallest number of hurricanes in a year during this period? And then what was the largest? Well, the smallest was 0, right? There were a couple of years. Oh, no. I'm sorry. I was confusing myself. No, what's the smallest number of hurricanes? It looks like 4. Right? It looks like 4 was the smallest number of hurricanes in a year. Right? And that only happened once. But there was a year that only saw 4 hurricanes. Okay. What's the largest? Largest number of hurricanes? Well, that was 19, right? So there was this one year where there were 19 hurricanes. So the largest was 19. Okay. Next one. It says, what number of hurricanes per year occurred most frequently? Okay. So what number of hurricanes occurred most frequently? Well, so this is asking us to kind of work backwards. It's saying, like, what was the largest frequency? Well, the largest frequency was this one right here, right? This number of hurricanes happened 10 times. So what number of hurricanes per year occurred most frequently? It must have been 11, right? 11. So there were 10 years in which 11 hurricanes. Ooh, I can't spell hurricanes. Hurricanes occurred. So 11, right? Okay. How many years were the hurricanes counted? Ooh, how many years were the hurricanes counted? That's a good question. How many years? Well, 1 year here, 1 year here, 6 years here, 6 years here, 9 years, 4 years, 6 years, and so forth, right? So the total number of years, I would need to add those up, right? Maybe I could do this. Maybe I could label these, right? So this happened once, this happened once, this happened 6 times, 9 times, 4 times, 6 times, 10 times, 5 times, 5 times, 3 times, once, and once. Okay, so I need to add those numbers up, right? I can say, well, the total number of years would have been 1 plus 1 plus 6 plus 6 plus 9 plus 4 plus 6 plus 10 plus 5 plus 5 plus 3 plus 1 plus 1. Okay, I can't get it all on the same page at the same time, but or all on the same screen at the same time. But that's what's going on there. So let's add those up. 1 plus 6 plus 6 plus 9 plus 4 plus 6 plus 10 plus 5 plus 5 plus 3 plus 1 plus 1 is 58. So they kept track of this for 58 years. Okay, so that's interesting. And finally, part D. In what percentage of years were there more than 10 hurricanes? More than 10 hurricanes. Well, let's see. So in these years, there were 10 or less. So the number of years where there were more than 10 hurricanes would be 10 plus 5 plus 5 plus 3 plus 1 plus 1. So, but we're asked for a percentage, right? So first we'll get the number, right? So number of years with more than 10 hurricanes is 11, right? So 10 plus 5 plus 5 plus 3 plus 1 plus 1. Which is 25. So what percentage of years were there more than 10 hurricanes? That would be 25 out of 58, right? Right, 25 out of 58 is about 0.431, right? So that's 43.1%. So almost half of the years had more than 10 hurricanes in them, which is kind of crazy. Okay, but anyway, that's that one. All right, so that's all I have to say for now about organizing data.